Hello and welcome to this presentation. My name is Mohsen Assadi. I'm professor at University of Stavanger, and I will present an ongoing project which has the consortium consisting of the university in Krakow in Poland, the company Movitek, and the University of Stavanger. The title of the project is Innovation in Underground Thermal Energy Storage with Borehole Heat Exchangers, and the EEA is the financer of the project. The project has been running for almost 1 year from October 2020, and it is a 3 years project. This nice picture shows the site of the project where the installation is going to take place. It is a palace outside Krakow. I will come back to the installation itself. The project idea is to bring theoretical and experimental studies together to improve the borehole heat exchanger designs and improve the performance of the whole installation and reduce the costs. Investigation of innovative borehole heat exchanger designs is a major part of this study. And we are going to combine theoretical studies, which means simulation and optimization based on parameter variation. And also we are going to implement data-driven modeling to support the monitoring of the installations after the installation using artificial intelligence. Finally, techno-economical optimization will be implemented to find the best technical and economical settings, and the wells will be installed in the real site, and the testing will provide the data that will be used for evaluation and validation of the models developed during the project. The project setup is actually based on 5 different work packages. Work package 1 is looking into the physics-based simulation and the modeling. We want to sort out the issues related to parameter variations and selection of the design of the heat exchangers. Work package 2 is supporting actually work package 1 in a way that the data-driven models, which are very fast in calculation and generating results, will be used to support the work package 1, which has a very time-consuming approaches with these mathematical models. Work package 4 is led by the heat exchanger manufacturer, and they are going to develop real case heat exchangers which are going to be evaluated in this project. We are going to do the studies prior to the design and manufacturing and try to find the best solution. Work package 5 is the installation work package, which means the planning of the drilling of the wells and installation, and finally taking into operation the whole setup. All these work packages gonna have interaction with each other, as well as all of them gonna give inputs to work package 3, which is the techno-economic analysis and the business model for the final product. A little bit more details about the work packages and the tasks to be carried out in those work packages. We have a special focus on the coaxial heat exchangers, borehole heat exchangers that are going to be installed. We need to understand the pressure losses, the heat transfer. We are aiming at developing a heat exchanger that has strong but thin external pipe, enabling high heat transfer, but in the same time being mechanical, have the mechanical strength to withstand the hydrostatic pressures. The model developed is based on this drawing, which gonna be then investigated from many different aspects. The impact of the design parameters will be studied. It is about the well depths and the pressures and the mechanical strengths of the construction, diameter and the wall thickness, which means that we want to have a tiny wall on the external pipe and thicker wall in the internal pipe, in a way that the internal pipe can be equipped with turbulators so that we can increase the heat transfer. However, pressure losses will be an important element to understand, so that the power used for pumping around the working fluid should not be more expensive than the heat extracted. Efficiency, should it be stated there, and that is obviously the most important element connected to the eccentricity, which means that if the inner pipe is not centralized inside the external pipe, is there any specific impact on the performance of the system and the efficiency of the installation? Because it is a costly measure to keep the inner pipe in the center. So these kind of questions should be answered by the numerical studies. Here we do have preliminary study results concerning the velocity of the flow in three-dimensional calculations to understand the impacts of the pressure loss, heat transfer, and so on. Furthermore, results are presented here. But generally speaking, these kind of simulations are time-consuming, and it need to be supported by data-driven models. And because of that, the results and the simulation data generated by running this kind of case-based studies are gathered in a database, which is then made available for the work package dealing with the data-driven modeling. Here we see the results of the first analysis on the eccentricity, which means that we have found out that keeping the inner pipe in the middle of the outer pipe is actually not providing very large advantage, but adds to the cost of the installation. So that is a good first indication for understanding of the important parameters. In the work package 2, historical data have been used already to investigate the setting of artificial intelligence-based model using artificial neural network. That model has provided us with a rather good understanding of the capability of the AI-based modeling. The work package 1 data from simulations, as I mentioned earlier, going to provide us with a database to be used for the modeling approach in the data-driven one, so that we can have models which can immediately give answers to change of the parameters without time-consuming simulation procedures. Finally, the data from the field will be used for development of the tools for monitoring and optimization of the operation beyond the project time. The results of the preliminary studies show that the experimental data, which has been historical data available, have been used for doing the ANN study, optimize the setup, and the results are very promising. What we had as measurement, it was the inlet and outlet temperature, inlet temperature of the flow into the borehole heat exchanger, the ambient conditions, the flow rate, and the pressure drop, and finally the outlet temperature from the well was predicted. And the settings of the ANN are listed here concerning the design and setup of the ANN model itself. And here is the preliminary result showing that the ANN has been able to predict the measured data with very high accuracy, which is very promising for the next steps of the project. In work package 3, we are going to gather the specific data from the site. We have already noticed that allowances and other kind of paperwork consume a lot of manpower and resources, and going to impact the economy of the installation. However, the inputs from work package 4 and 5 concerning the manufacturing, installation cost, and operation of the system will have a large impact on the techno-economic analysis. Parameter identification for the modeling will be considered, as well as the estimation of the installation, operation, and maintenance costs. Finally, the impact of standardization to reduce the cost in repeated installations will also be investigated here. Work package 4, which is actually focusing on the installation of the borehole heat exchanger, is bringing to this project innovative design based on composite coaxial borehole heat exchanger. As already mentioned, it will be stronger and mechanical strength of the external pipe with tiny wall, and then the thicker inner wall for the turbulator installations. Novel solutions will be tested. It means that the number of wells, which will be 18 installed in the site, will be equipped with different type of borehole heat exchangers at different depths, and thereby we can compare the installation and operation and the performance cost-wise and technology-wise, which is very important for the future. Obviously, the experience transferred from the previous studies to this one will enable to enhance the prototype design. The manufacturing, installation, and testing will be carried out in collaboration with other work packages and in close collaboration with all other work packages. We are going to find out the impact of different parameters on the cost of manufacturing, on the cost of operation, and also looking into different geometries for the borehole heat exchangers, material selection, as well as the working material and the installation effect. Work package 5 is actually the installation part of the project. As you can see, the site here with the highlighted area in orange with those circles which are indicating the wells to be drilled. Close up here shows the opportunities for drilling the wells, and then the interaction between the wells in terms of thermal interaction, heat losses, and so will be investigated prior to the installation. As you can see here in the following tables, we are putting together a number of wells with different type of heat exchangers, with different design parameters, and these will be operated, experimental data will be gathered, and finally the optimized solution will be evaluated and investigated for future development of this borehole heat exchanger installations. By that, we reach the conclusions and the way forward in this project. Physics-based models are used to do parameter investigation, identify the best options of the combination of data. The databases generated are going to be used for development of artificial intelligence-based models, which are very fast in simulation and generation of data. Manufacturing and installation will be based on the outcome of the theoretical studies. And finally, the life cycle assessment will be carried out from the economic and environmental point of view. As I already mentioned, the regulatory frameworks have been a challenge in itself. So we are going to look into what specific site considerations need to be taken into account from the planning and installation point of view. but also the instrumentation for continuous monitoring and evaluation of the performance of the wells will be one of the challenges and tasks to be taken care of by the project group. Thank you very much for your attention, and I'm looking forward to hear your comments and possibly answer your questions. Thank you.